this Xlab Fridays, that is our first virtual online event. Previous events, or we have it in the Tech Hub, which is in Florida. So without much ado, I'll just call on Kobe. We have just a minute to start the real talk, so that Kobe will take us through what solid principles in object-oriented programming is. If you have any submissions, you can raise your hands in the group. During the talk, we'll provide space or time so that if you have any questions or anything, you can just raise your hand. If it's time for me to give you the opportunity to talk, I'll give you. If it's not time, you can text or write your answer in the chat in the meeting, and then Kobe will address your submissions. That's if there is time. So it's 3. So Kobe, I'll leave you so that you can take charge. All right.
All right, yeah, so as Chris just said, the topic is on solid principles. And I think by the time we go through this topic, we are going to have a deep understanding of this principle and how to apply it in projects. Yeah, every profession has some principles they follow. Even the lawyers have it, doctors have it, almost every profession. And software engineers or programmers, we are not different. We also have to follow some principles. And this is not the only principle, actually. This is just some or one of the principles that if we have it in our tool belt, it's going to help us really come up with nice, good, clean, and maintainable software. Yeah, so this is me. My name is Kobna Lawson. I'm a full stack .NET developer. I currently work at University of Energy and Natural Resources. Yeah, so our talk is on solid principles, and it's an acronym of acronyms. So the first acronym is the SRP, which is single responsibility principle, the OCP, which is the open close principle, and the LSP, the list scope substitution, and the ISP, which is interface segregation principle. And we also have the dependency inversion principle, which is the DIP. I might not present it according to how I've arranged it, but at the end of the day, we'll still go through all these principles. So we first start with the single responsibility principle. This principle states that a class should have only one reason to change. Every class we create, it should only have one reason to change. And what we mean by a reason to change, or what we mean by one reason to change, basically a reason to change is a person or a group of people who are asking you to make a change to that class. So a person or a group of people who are asking you to make a change according to their needs or their requirement in that class. So assuming you create a class which maybe 2 groups of people or 2 persons or 2 people are coming to ask you to or requesting for a change, then you are not adhering to this single responsibility principle. We want to create those classes according to those individuals. We want to create classes with the same concerns, classes with the same, we are aiming at solving one problem. So for instance, let's say you can have a class like student, which has things which is pertaining to student. And so you can have a class like account, which has things which is pertaining to an account. So how do we deal with this single responsibility principle, or how do we achieve single responsibility principle? We just have to, what we have to do is we gather together things that change for the same reason. So as I said, the student, you put together things which are involved in the student, maybe add student, maybe update student, and so on. So there are things which are for the same reason. And some things which may change for the same reason, things which are operating for the same reason. And you also separate together things which may change for different reasons. So for instance, you might not want to add account staff in a student class. You want to put things relating to the account in an account class and put things relating to student in a student class. So for instance, I have this simple class here, the typical crude operation, and this is a school repository. You can see that it has methods like add school, get school, the get schools, also have an update school. Basically, whatever is happening here is something which is related to school. Or all the methods here, they'll change for the same reason. They are changing for the school repository. So if something should change or we need to make any changes, it's something that is relating to school. We can't have a method like, let's say, a course, a class like a method, maybe add course. or maybe get student by ID in this class. In such a situation, maybe you have two persons or two groups in the same class. So now the class will not have a single responsibility, but you try as much as possible to separate all those responsibilities into their separate classes, just as we've done for the school repository. Because it's just one class, there's doing performing some crude operations for the school and the school alone. So you can also have another class, the student repository, performing a crude operation for the student. So that anytime you have problem in the student, you only attend to the student. If you have problem in the school, you only attend to the school. We want to keep this separation so that it helps you so I don't introduce bugs. The reason why we are doing all these things. So for instance, if you have maybe student and school in the same class, and you want to fix something in the student class, by the end of the day, you end up causing a problem in the school method or something. You've introduced a bug which you don't know. It's like giving your car to someone to maybe your windscreen. You could not roll your windscreen, so you gave it to a mechanic to fix it, and you came, everything is working fine, but you can't start the car. Yeah, that's exactly what we want to avoid. So we want to put things in separate classes so that when we are making changes, we don't introduce some bugs which we might, sometimes it's not our fault, you understand, but you end up introducing the bug. So that's why we have this principle. But yeah, this is just a real world demonstration of what is single responsibility principle. You can see we have a sound bar. We have a sound bar here. We have a subwoofer for playing the low frequencies. We have the sound bar giving us some high and mid frequencies. We have some real world things which does not obey the single responsibility nevertheless, but it still works. Even the computer we use is a multi-purpose computer. Some use it for coding, others use it for watching video. Everybody has his own reason, but it works all right. But we don't want that in our code. We want our code to have a single responsibility. All right, so I think we'll look at the next principle, which is the interface segregation principle. It's similar to single responsibility principle. What is it saying? It says no client should be forced to depend on methods it does not use. Essentially, what I'm trying to say is that when we want to create an interface, you create an interface for a particular class, something that is very specific to that class. You don't create one giant or one big interface and expect everyone to implement what is in there. So you just create specific interfaces that are needed by clients. So this is just an interface for the school repository we just saw. So it just has specific methods: add school, get school, and we have the get schools. Also have update school. So this is just something specific needed by the student, the school repository. We don't have any other stuff. And basically that's what interface segregation principle is saying. So when you are creating an interface, it should be specific. It just should be specific to the client who is going to consume it. You shouldn't have more than the client needs, because you might end up having some method which is there, but you just have true not implemented exception. And someone might call it in future and it will throw that exception. We want to avoid that. So anytime you are creating an interface, you also should be specific. So this is just a single responsibility principle for creating interfaces. And that's the interface segregation principle. And we also have the open-close principle. The open-close principle is also an interesting one. It says class should be open for extension, but closed to modification, or in other words, closed to change. And how is this possible? I mean, but this rule in the first place should be applied in production, during production after everything has been tested, we publish our app, it's running, and new features come in or new changes come in. The code that is already running, this rule says you are not supposed to touch it. But then we should go ahead and add our new changes. Nevertheless, we should extend the class. We should add our new features, but we shouldn't touch that code again. Yeah, why? Because it all comes back to the same reason. Going to touch that code, you might introduce a bug. And this code has already been tested, it's in production, it's working. Why do you want to touch it? And also, let me put it that way, you don't want to introduce a bug, you don't want to even compile it again, because once you touch it, you're supposed to compile that class again. We don't want to do that. We want to compile the new code We don't want to recompile the old code. We just want to compile the new code. So how do we do this? So this means we should be able to change the class without changing the source code. In other words, whenever there's a new feature, you have to write a new class to modify the old class. So whenever there's a new change or there's something you have to do, anytime there's a new features means new class. New feature means new class. You don't modify the old class. You always create a lot of classes, or you always create new classes to extend the existing class. And in practice, sometimes you might make some minimum amount of change in the old system, but not necessarily your business logic. When I say the old system, I mean probably your configuration side, the configuration aspect of your code where you have your startup or where you are doing some dependency injection, that aspect. You might tackle it, you might make some minimum changes. Then the new changes or the maximum changes happen in the new class. So the new class that you want to create, that's where you maximum changes are going to happen. That's where you're going to do most of your changes. That's where you're going to write most of the stuff. Yeah, basically that's the open close principle. Yeah, so how do we achieve that? You can use inheritance, but I'm not going to talk on that. It's actually very easy to explain to beginners, and it's very easy to understand the inheritance principle. But inheritance comes with its own challenges, so I'll not demonstrate that today. But we look at also the commands there. The commands, I think, is a natural way of obeying the open close principle. It's just natural because every command is different from the other. Every command is different. Let's take it in real world. Let's take a real world example. Let's say if I tell you to kneel down, or I tell you to come, they are different things not together, so they can't be in the same class. Yeah, so in the same way, when we come to programming, every command essentially is a new class. So whenever there's a change or there's a new requirement or a new feature, just create a new command. And so you don't even have time, or you don't even think of going to edit the existing code, because you just have to create new command. There's no need to change the existing code. Yeah, so maybe I think we would like to look at something, maybe how to, let me demonstrate the command. Let's have some snippets I'll use. I can show you here on using the commands. Yeah, so this is just a simple example of a command. Okay, but first of all, let's look at this. I have this interface. I have the I command. So this is the command interface. So we have a request, or request. In other words, what we mean is here is that a parameter that is coming, and we have our result. So this is the general command interface for all the commands. All the commands will be inheriting from this. And I also have the somehow ask why, because I already have this I command. I'm just using this so that I can be able to instantiate the real classes through dependency injection. That's why I have this. It's not, this is just, yeah. Okay, but this is what I want you us to look at. This is the main command class. So this is just what we are only doing is that we want to execute something here. We want to execute. So you just pass in your request. We just take, so this command, for instance, is getting some results based on this request. So say it's a get exam results command. So the request has some parameters. So the exams command request, when you go inside, you see that it has some parameters here that we are using in our command. So for instance, you just implement this command maybe from here to here and you are done. Maybe next time when I say add results, or maybe add exam results, you can't come back to this command and update it. What it means is that you have to create a new command and use it. And so naturally, when you are using commands, you tend to obey the open close principle. It just flows. It flows naturally. And commands, when you use commands to you have to have some command processors, and so you need to use, let's see, you have I have some command processor here. Yeah, so I have this. It uses reflection to locate all your various commands. Just pass in the request, and you can use reflection to get the actual implementation for it. So I don't have to manually come to change the class, or you don't have to manually use switch case or something to do it. So once you create your command, you can have the other tools, not necessarily using this. I created it for my own use, but the other tools like Mediator, the other libraries that can help you do that. So once you create your commands, those things, those libraries will help you instantiate the various commands at runtime. So yours is just creating a command. So it helps you just focus on the command you are creating. You don't touch other parts of the code. And with the open close principle, when there's a bug, you're allowed to come and change it. So assuming there's a bug in this command, I'm allowed to come and change it, but I only change this class. I only do the changes here, so I don't touch the other parts of my code. The other parts of my code still remains intact. And that's the good thing about commands, and that's also what we want to achieve by the open close principle. Because once you are changing it in that particular class, the rest of the class it still remains intact. The rest of the class still remains unchanged. Yeah, so we don't have much time. Let's move to the other principle. Well, that's the dependency inversion principle. Dependency inversion principle. Oh, dependency inversion. Basically, what they're saying is that high-level models should not depend on low-level models. Both should depend on abstraction. High-level models should not depend on low-level models. Both should depend on abstraction. So let's use this diagram as an example. Additionally, when you write an application, maybe you have class A, class B, and you want to connect, maybe class A want to connect to class B, or class A want to communicate to class B. What you do is that you just instantiate class B in class A, maybe new class B inside class A. And that's what figure 1 is showing. Figure 1 is trying to say that class A is pointing directly to class B. At figure 2 is telling us that no, even if you want to communicate with class B, it's true that you can connect to class B directly, but rather use interface A. So that both class A's, as you can see, the arrow direction, you can see that class A is pointing to interface A, and that's object A is pointing to interface A, and object B is pointing to interface B. But at runtime, the diagram is going to look like figure A because at runtime, of course, we are going to need object B, so you have to point to it directly. But during compile time, during the time we are building the application, we want to depend on an abstraction. Basically, that's what dependency inversion principle is saying. That anytime you have two models and you want to depend on, you want to communicate, you want to have a communication, don't directly link them together, but rather provide an abstraction. Because once there's an abstraction, it gives us the flexibility to do a lot of things. When there's an abstraction, when even there's a problem, it doesn't affect the other problems, the other classes. When there's an abstraction, there's a lot of, you can do a lot of things like swapping and so on and so forth. So we shouldn't just depend on it. We should just give an abstraction. So I think this principle, hardware people understand this than software development. Is that you can even check your laptop. There are a lot of ports. They could have wired their cables to it directly, which means when you want to go out, you have to carry your monitor, your keyboard, and everything. But it's just a port. It's a form of an abstraction, right? So that when you really need it, you link the actual thing to it. And that is what we are saying. Provide an abstraction. When you really need it, you connect to it. But during the time of development, just give an abstraction. Just give an abstraction. So high-level models should provide abstraction. You know, like high-level models should not depend on low-level models, but both should depend on abstraction. That's basically what this calls what the dependency inversion principle is saying. I don't know whether my explanation makes sense, but okay, let me see if I can show some simple implement, what do you call it? Some simple demo here. Okay, so okay, let's use this for instance. Okay, so let's say this is my controller. Within my controller, I want to, okay, I don't even want to use this. Let's use this. Maybe within my controller, I want this class, this department service. I want to use it. I want to use a method called add department. But instead of depending on the department class, I depend on an abstraction. That's the interface rather. I call that interface, but at runtime, we are going to inject the actual department service into this controller. But after now that I'm the controller, I don't want to depend on the department service, but I want to depend on the interface. And that is what dependency inversion principle is telling us, that we should always depend on abstraction. We should always depend on abstraction. So abstraction means, in this case, means an interface. Always make sure there's an interface there in which we are all communicating via that interface. We shouldn't link to each other directly. So you can see now we have an interface. When we run the program, you can inject the department service here. You can also, using this I command, you can inject this command processor into this class. Okay, I think that is enough. Let's look at the next principle, which is the list of substitution principle. What is happening? What is happening to my slide? Yeah, list of substitution principle. It's also, I think it's also building on the dependency inversion principle, the list of substitution. It's all about substitutability. And what it's trying to say is that assuming you have, assuming S is a subtype of T, and T, oh, sorry. So assuming, if S is a subtype of T, then object of T may be replaced with object of S. In other words, let's say if S is inheriting from T, then object of T may be replaced with objects of type S. I don't know if, let me put it again. If S is inheriting from T, and let's say S is also inheriting from T, then objects of T can be replaced with S. Any object, let's say any object which is also inheriting from T can be replaced with S, as the principle says. So assuming if S is a subtype of T, and then objects of T may be replaced with objects of type S. It's basically building on this point, this dependency inversion principle, that we should put an abstraction there. So now, if there's an abstraction there, anybody who is inheriting from that abstraction or that interface, any class which is inheriting from that interface can be substituted with whatever is there. And yeah, as I said, I demonstrated with the hardware, this is also the same thing. So you see, there are a lot of ports on the laptop. And let's use even the USB, for example. Through the USB, you can extend your storage. You can just connect an external drive. Using the USB, you can even connect your phone to it, access things on your phone through the same USB. You can even connect your computer speakers, use the USB to power it, to play songs for you. There are a lot of things you can do connecting to that, because it is implementing the USB interface. And that is what list of substitution is saying. You can substitute a lot of devices which is implementing the USB interface, and it will work perfectly. If your class is tracked, we want our classes or our program to behave like this. So we can have an interface. Once then, we can only achieve that when we have an interface, and a lot of classes which are inheriting from that interface can be substitutable. We can swap them as and when we want. It seems a little abstract. Let's look at the real implementation. I have this. Let's look at this class. What about my connection string, and don't judge me? Yeah, but let's look at this. We have a product repository is inheriting from iProduct repository, and basically this is using pure edu.net. We have the add product, update products, blah blah blah. We just run it on edu.net. And we also have another class, the same class, but this is using NT framework. I use EF, and it also have the iProduct repository. So we also have add products, update, delete products. All the methods here are here. We can put them side by side and check. You can see that all the methods we have here, they are also here. What does this mean? This means that at any point in time, we can swap these two classes, or at any point in time, these two classes are substitutable. So I can decide that this time around, normally we use NT framework in all the projects we do, or whatever. I can decide this time around, I don't want to use NT framework. I want to trash NT framework. I want to use edu.net. I want to use something native. I want to use something different. You can use edu.net and it will work, because they are implementing the same interface. So you can substitute this product repository with the EF product repository. I can even create a file system, maybe something product repository underscore file system, and this is inheriting from product repository. And I'll say this time, I'm not even going to use a database at all. I'm going to run everything on files. And once it is implementing the interface, we can substitute it, we can swap it, and no one knows what is happening. The consumer does not know who is happening because it is depending on that interface. It is depending on the abstraction. So anytime we have classes which are depending on these abstractions, let's also, based on this principle, let's look at this. So it says, if S is a subtype of T, so let's come back. So if this product repository is a subtype of I product repository, then objects of type T may be replaced with objects of type S. So in other words, we can also have objects of type this product, I product repository. In other words, objects which are inheriting from the I product repository like this. Maybe EF core product repository is inheriting from this. You can use this, you can pick this and come and replace it with this. Let me show you what I'm talking about. Let me show you what I'm talking about like this. So this is just, oh, what is that? So this is my configuration class. I do my dependency injection and stuff with it. I can decide at this time, I don't want empty framework. I want to replace it with a product repository. And when I run my code, it should work. Unfortunately, this program does not run. I'm not going to run it to show you, but in principle, it should work because it's also implementing I product repository. I can easily swap it like this in my configuration and run it, and it will be using a do.net. Yeah, basically that's what the list scope substitution principle is telling us. Yeah. And on that note, I want to end my presentation here. We don't have a lot of time, so it should be brief. And if there are questions, I think, yeah, Chris, I think I'm done. Hello. Hey. Hello.
Yes, hello, Kobe.
Yeah.
Yeah, I'm still with you.
Yeah, I think I'm done too.
Yes, thank you very much. Solid principles in 30 minutes. Wow, that was just an overview. So I think I saw Abu Sharif's hands up.
Okay,
So,
okay.
Yeah, Abu Sharif, if you have any question, I'm going to unmute you so that I can ask.
Okay, so let's
Okay, Abu Sharif, I've asked you to unmute yourself.
Yes, good afternoon.
Good afternoon.
Good afternoon.
First of all, thank you very much for this opportunity, and I'm very grateful. Well, I would like to know if it's possible to have a copy of this video for future reference because I find it very educative and interesting.
Well, Chris, I think Chris will answer this.
Sharif, I think you stated that in the chats, in the group chats, and I responded. So we'll upload it on our on our YouTube channel, so that you can all go there and watch it. So we don't allow, I wouldn't allow you to bother yourself recording the whole thing. We are recording for you, so there's no need for you to record. Just follow us across our social media handles as soon as it's been uploaded on YouTube, and that will be right away. We share the update there so that you can just watch from there for future reference. I believe that answers your question.
Well, for now, I don't have a question. I think I'm all right with that.
Okay. All right. Thank you. Okay. So please, if you have any question, you can put it in the chat or you can raise your hand so that I can. Okay, Eddie. You have a question, right? I'm unmuting you. Okay, so please let us hear you.
Hello, and my name is Edward Ameu. Thank you very much for this submission. I've really learned a lot. But I'm a PHP developer, okay, and I've been coding with PHP, but I've never come across this solid principle before. I don't know. Do you think I'll be able to implement it inside PHP, and how fast will it be if I want to actually implement it? Thank you.
Yeah, sure. As long as you can implement object-oriented concepts in your language, you can implement this solid principles. I know your PHP, though it's mainly a scripting language, but I can do some object-oriented stuff with PHP. So, which means you can also do solid principles in PHP if you want. Yeah, if you go to Google right now, just type solid principles in PHP, you see a lot of links coming up. Yeah, so I think you should be able to do it. And any object-oriented language, or even if some languages are multi-paradigm, but they still have some object-oriented concepts in there. So I think you can, as long as you have some object-oriented concepts in your language, you can try it. Yeah. Eddie, is your question answered? Hello. Chris?
Sorry. Sorry. Yeah, I think I got it. Yeah. Thank you very much.
Oh, all right,
I think
all right.
I'll
You're
just
welcome.
do what he just said and then try to see if I'll be able to implement it in my project going forward.
Yeah, you're
I hope
welcome.
you are call away if I need you to help me with it.
Oh, sure. Yeah, sure.
Thank you very much for your answer.
Okay, so please, do we have any other question? Okay. So, Abu Sharif, I'm sharing the links to our social media handle here. So it's in the chat, so you can follow us across the social media. And so that once the video is shared, then you find it. Okay. So I think no question. So if there's no question, I would like to thank you all very much for your time today at Xlab Friday. So just follow us on social media. I've shared a link in the chat, so you can all follow us over there so that you get to know our upcoming events and such talks, so that you can all learn something from whatever we are ready to share. So I think a hand is raised. Samuel has a question. Okay, Samuel. So I've asked you to unmute yourself. So you are ready for your question.
Hello, Mr. Lawson. I followed your talk. Very interesting. What is this something I should learn by heart, or how best can I master this concept? Because some of them are very confusing. This cost principle, this cost substitution principle, and the one with the interface. I've forgotten that one.
Interface segregation principle.
Yes, and the substitution one. I was confused about those things. How best can I implement these things? Is it something I have to learn by heart, or what is the best way to learn these principles and use them in my coding activity?
All right. Okay. First of all, I wouldn't say it's something that you have to know by heart, but it's something that you should know. But it comes with time. You can't just say, "Hey, now I've read some book on solid principles, so I'm going to implement it in my project." But it's a gradual step. And then as each principle, all the principles they are somehow linked to each other. So okay. Yeah, so solving one principle, it might lead you to implementing the other principle and the other. So it's just a systematic process. You try maybe bit by bit. Maybe you can even start with the single responsibility principle. Maybe, okay, this is my class. I want to separate my concerns according to different classes, and you start by that. Then you asked about the interface segregation principle and the list code substitution. Okay, basically, interface segregation principle is, as I said, it's just like a single responsibility principle for your classes. But sometimes during the trying to sometimes you have maybe if it's a new project you are starting, I think maybe you might not face that problem. But maybe some projects it's already there, you want to refactor it and stuff. So sometimes using this principle might be a challenge. You can't just go and say you are going to apply those principles. You might have some challenge doing it. So you can create some what do you call it? Some, so maybe some your own APIs, or let's say I'll call it. They have a term about you should create something on top, a layer, your own layer on top of what exists, so that you start applying this. You fix the problem, then with time you start solving it. I don't know whether I don't know whether my explanation makes sense, but what I'm trying to say is that you can create a layer on top of the existing code that is a much cleaner, that follows this principle. Then you can use it to fix that challenge that you have. Yeah, I don't know if I've.
Yeah. So what I understood was it is a gradual process, and I have to do it.
Yeah. It's
with time. I'll get it.
It's a gradual process.
All right. Okay. Thank you.
Thank you, Sami, for your question. Okay, and thanks, Kobe, for the response. Is there any other question from anyone? Or if there is another you would like to add? Okay. So silence, they say, is golden.
Hey, there's no question. It means either they didn't understand it or they really understand it very well.
Very well, yes. Okay, so Richard, you just said you are late. Yes, with a sad smiley. We would share the video on our YouTube channel, and the link will be shared also across our social media handles. So the links, you find the links in the chat, and follow us.
As I see the laugh now, I don't see the food cup.
You can follow us across then.
You see that they laughing.
Okay, so Sam, is this Sam? Sam, you have your hands up. Okay, so you can unmute and ask your question.
Okay, hi. Question is there any architecture that encompasses the prosperity? Maybe you know how maybe there's MVI, MVC.
Hello, wait. I didn't start it. There was a break, so if you want to.
Can you hear me?
Yeah, I can hear you.
Yes. So I was asking if there is any architecture that encompasses the entire solid principles correctly. Like maybe, you know, the MVC, MVVM. Is there any architecture that we would recommend when working with the solid principles?
Okay. I will not say maybe use MVC or maybe use MVVM and so on forth. But as you are implementing those things, you should, some of these, let's say, frameworks that you're talking about might be using it somehow, but this is not, what this talk is not about, it's not framework specific. It's just a general knowledge that you can be using MVC and apply solid principles in it. You can be using MVVM and apply solid principles in it. I don't know, but you have an out-of-the-box framework which has, that one I don't know about that, but this is something, soft skills that you as a developer should possess. It should not be possessed in the framework. It should be in the developer. Yeah, that's what I can tell you. I don't know if that answers your question. Hello.
Okay, Kobe, thanks for the submission. Sam, I believe your question was answered well. So I think it's time and we'll have to go. But let's just keep the conversation going. Yeah, let's keep the conversation ongoing. So we'll continue on social media. Once we share the link, if you have any question or any submission, you can just add it to the link and continue from there. So from Xlab, we want to say thank you very much for your time. just stay tuned with us. I'll say it again on our website or across our social media so that we just have further interactions with this program and the upcoming one. So thank you and enjoy the rest of your day. Bye-bye.
All right.